Hi, my name is Roy Moffatt. I'm with Vario Neurosensor. I'd just like to take a couple of minutes to try to explain to you the effect that mental fatigue has upon load cells, especially load cells which are used for long-term endurance testing. Mental fatigue is a term which is bandied about. A lot of people don't really understand its effect. And what I'd like to do is use this piece of metal just to show you what the effect is. It's only galvanized steel, it's not very thick, but because the edges are rolled, it's quite substantial. There's no way that I could break that without a saw or not use my hands. However, if I place it in a vise and bend it, and then bend it back again, you'll see that very quickly, within a few moments, I can break it. Okay, that's due to metal fatigue. And what's happened here can happen in a load cell. And I'm just going to go back to my office now and I can show you what the effect is, why it happens, and what we can do about it. That demonstration that you just saw shows how metal fatigue can result in the failure of a piece of metal. How quickly that occurs depends upon how far you actually bend it and the frequency with which you bend it. Now when you use a load cell for testing applications, especially on something like a 4-poster rig, okay, you're applying a force and reversing a force very quickly over a long period of time to see the effect that this could have perhaps on a vehicle suspension or other parts that you're testing. That same fatigue that you saw can take place inside the load cell. And the only way to prevent that taking place is to really limit the movement that you get within the load cell. And that's where I'd like to introduce you to this range of load cells. This is our fatigue rated range of load cells. It consists of 2 rings linked by a diaphragm. This diaphragm is quite thick, probably 3-4 millimeters thick. Consequently, it's very, very stiff. Of all the load cells on the market, these are probably the load cells that have the smallest deflection under full load. Normally when you have a small deflection, you suffer from the problem that you don't get a very big signal from the strain gauges. That's compensated for in this load cell because the gauges are placed in holes drilled in through the periphery into this actual web, so they sit right here inside the web at the very center of the web. This means that we can get a good signal. Consequently, we can guarantee that on a load cell like this we can give you 1 billion cycles, full reversal to its maximum capacity. We do that by over-engineering and producing an even stiffer load cell. Even with a load cell, if it doesn't fail for mechanical reasons, it can fail for electrical reasons. And another advantage of this type of construction is that we can put multiple strain gauge bridges in. So you could have this unit, for instance, fitted with 3 strain gauge bridges. So if you were testing and doing a test over the course of 9 months, say, and 6 months in, one of the bridges failed, you wouldn't have to recalibrate and lose all your results and everything else. You can just use one of the other bridges that are in there. So that's the range of our FFL load cells. You'll find this on the website of our sister company. That's www.ixthus, that's ixthus.com. And I'm sure if you're looking for long-term longevity from your load cells, the FFL is the one that you need to consider. Thank you very much.